Okay, good afternoon. Are there any questions for me? The midterm I haven't finished marking. I hope to finish it sometime this week, and I will upload the marks onto Moodle. Assignment 3 is also with the TA, and as soon as that's done, I will update the marks on the Moodle as well. So currently there are 2 marks for assignment 1 and 2 on Moodle, and check that you're comfortable with that. And if are there any questions? No? The class is going well for you, or how was the exam? Good? Easy? If you did the assignment 3, it should have been easy. It was basically model after assignment 3, right? Just changing the numbers and stuff here and there a little bit. Okay, so far we have kind of learned the MATLAB language, the basic rudiments of like the alphabets and words. Now we want to put them together to write small programs. It's like learning a language where you're ready to write short stories and then move on to bigger things. So today I'm going to introduce this idea of functions and scripts, okay, and what they are, what is the structure, how we go about building them, and then we'll illustrate it with a couple of examples. And the next assignment, I've almost finished it, but I have not uploaded it, but I will upload it this afternoon. And there are 4 problems here. Now we are getting into problem solving mode. Okay, so you will have to write functions for solving 4 different problems. These are extremely simple problems, but the struggle would be in writing the MATLAB function and running it. And so what I'm going to illustrate today will be essentially what you will be practicing in assignment 4. Okay, so in the previous lecture we looked at array addressing, how to address, how to change matrices, about precedence ordering, and about manipulation of matrices using various functions. So these are all built-in functions. There are so many of those built-in functions already in MATLAB. That's what makes it very powerful. So we have been using the functions that are built in for us. Excuse me, I have a pretty bad cold, so this may be a tough lecture. Let's see how far we can make. Okay, so now we are going to learn to write our own functions, and in doing so we will use the functions that are built in to solve a variety of problems. Okay, so example of a dot product, you must have seen this in linear algebra. Okay, so this is a definition of 2 vectors. If you give me 2 vectors A and B, okay, A is a vector, meaning it has a set of numbers. It may have numbers like 0.5, 0.5, and B may have 0.5 minus 0.5, for example. Meaning if this is my x coordinate and that is my y coordinate, a vector A at 45-degree angle, if I go 0.5 on the x-axis, I'm going to go 0.5 on the y-axis, so that is a point on that vector A. And similarly, vector B, you go 0.5 on, I guess, the negative x-axis, and then go, so I put a minus sign there and put a plus sign there. Okay, so we represent points by vector in space, and we'll give the components of that. So when I say the dot product of A and B, the definition from linear algebra is given by this equation. That basically means take every element of A, multiply it with the corresponding element of B, and then add them up. Okay, AI, BI, summation over I. That is how we define a dot product or an inner product. So if I want to build a MATLAB function that takes these 2 inputs, so these are the 2 inputs, vector A and vector B, and I want to calculate the output C, which is A dot B. Okay, how would that function look like? So let's look at the structure, and then we'll actually go to MATLAB and run. So any function in MATLAB must start with the keyword function. It must be in a file. You will store each function in a separate file. These files are called .m files because they have an extension of .m, but you can give it any name that you want. Here I'm calling it a dot because it represents a dot product. You can call it .prod if you like, whatever name that you can give. Okay, so when you type dot, for example, in MATLAB, it will go and search for that function, that file, take the contents of that file and parse it. Typically what we have done so far is go into MATLAB, type one command, and it parses that command, tries to figure out what you mean and executes it and gives you the output. Now we are developing the ability where we pass the control to an entire set of functions, set of lines. And because the calculations involved maybe are perhaps a little bit more complicated, okay? So it will take those inputs, and the typical structure is function, space, and then the output, okay? You have to have, it can have more than one output. In this particular case, it has only one output, C, equals the name of the function. I'm calling it as dot, and I'm storing it in a file called .m. And then open parenthesis and identify all the inputs to that function. Close parenthesis. So the very first line must contain that syntax exactly as it is shown. Function, space, a set of output variables, equals a name and a set of input variables in parentheses. And then what would happen is when you execute that function, I will show you what that means. When you execute that function, MATLAB passes the control to this particular file, and this file says I can define the values for A and B to be anything I want. Actual numbers will be defined at the time that you execute. Then these you should know by now. Okay, what do you think the second line does? N equals length A. Length is a built-in function. It takes A, counts the number of elements in that vector, and stores it in a variable called n. The next statement takes B, counts the number of elements in B, that is the length of B, and stores it n. Now the inner product is defined only when you have same number of elements on both the vectors. If they have two different number of elements, you cannot define a dot product. Okay. So the next thing is we check. So if m, this means not equal to. Okay. So m not equal to n. If m is not equal to n, if that condition is true, then print out the error message. Now error is also a built-in function. It takes an input. What is the input to that function? In this particular case, it is the string. So the error function takes that string and puts it onto the screen, and then it stops, it exits from that function. So if there is an error condition, it will quit from that function. If m is equal to n, then this condition is not satisfied, so it bypasses it. So it will execute this part only if that condition is true. We're going to see a few more of these programming constructs, if, then, while, these for loops. These are the three important programming constructs that we will see pretty soon. Okay. So if the condition is not satisfied, that means if m is not equal to, if m is equal to n, then this condition is false. If it is false, what is inside will not be executed. The control transfers to the next executable line, which is this. And what does this do? C equals sum A dot star B. Now, are you able to understand what this line does? By the time I have verified A and B contain the same number of elements, so what does this dot star do? You cannot afford to forget whatever you have seen before because we're building on that. Dot star does a element by element multiplication, meaning takes A1 and B1 multiplies it, A2 and B2 multiplies it, A3 and B3 multiplies it. So it returns a vector containing as many elements as in A and B, but containing their product. And that result is passed to sum. So sum basically takes all the elements in the vector and adds it up. Okay, so that sum is this, and A, B, that is this part. And that is stored in C. So an important thing to notice is the output from here must appear somewhere in your function on the left hand side, because that's what is calculated. So C must be calculated somewhere before it can be returned to where it was called from. Okay? Excuse me. And similarly, A and B must be used. The inputs must be used somewhere on the right hand side. Because what we are trying to do is take the input, do something with it, some operation with it, produce an output and return the output. Any questions on that? Because that simple function captures the basic idea of what a function is. What is the structure of a function in MATLAB? I mean, most other programming languages, whether it is C or Pascal or Python, whatever it is. Any questions on that? Is that clear? Okay, let's go and write that function now and execute it to see how it runs. Okay. In fact, I have a function called dot, but I'm going to delete that so that I write it from scratch in front of you. Okay. So how do I write a function? When I am in the MATLAB window, I enter the command edit. Edit, it brings up an editor, and you can give it a file name .m. So what I'm saying here is edit a new file, name it as .m. Okay, when I do that, it opens up. Okay, it opens up a function which already exists. This is one of the built-in functions. Okay, so let me create a new function. So this is an editor. An editor allows you to edit and put anything into that file and save it as a file. Okay, so in fact, when you create a new function, it gives you already the format. The first line must be function and then output argument. So here I'm going to put C, and then untitled. So here I'm going to change this as dot. Okay, or maybe I'll change it as my dot because there is already a dot that exists before. And input argument. So I'm going to write it as A comma B. Okay, so this is how you write a function. Okay, the first line identifies the name of the file, the inputs and the outputs. Okay, and then you have a percent sign. These percent signs are called help. Whenever you ask for help on any command, it will give you some help that we have already seen before. For example, if I go and type help sign, on the sign function, it will give me a little bit of help. How to use it, what does it do, things like that. So in the same way, when I write a function, I need to be able to help the other user of this function what it means. Okay, so I can go and put those helps as comments. Percent sign is a comment, and any comment that follows immediately the function line will be treated as the help. So I can put this function calculates the dot product of two vectors. Okay, then you can say usage. How do you want to use it? C equals my dot A comma B. That's how you would use it. So then you can describe what A and B are. Okay, A and B are vectors of the same length. Okay. So you can put any number of lines like that, that will be help, and the way that you break that help is put a blank line. So up to that point will be treated as help. After that you start defining what your actual function is. Okay. So I could, for example, simply put C equals sum A dot star B and be done with it. Okay. That will actually calculate the dot product and return it in C. But shall we try what happens if I save this as my dot m. Okay, so the file name and the function name match. Okay, so the function name here is my dot and the file name is also called my dot. I've saved it now. You can see in here. Okay, so if I go to the command window, a new function is known to MATLAB automatically. Okay, so if I say, for example, help my dot, it prints out the first three lines. That is what is considered as help. Okay, I can say type my dot. Okay, I don't have to put the M because M is a natural extension in MATLAB. Okay, so when I say type, it actually lists the entire function. Okay, whatever is in the file, it lists it onto the screen. This is how you would generate a copy of the function that you write for submission. Okay, one of the things that you would do is there is a command called diary, and if you say diary on, it will start keeping track of everything that you do on the command window from that point on into a separate file called a diary file. Okay, and if I say, for example, type my dot, it not only types here, but it keeps a copy of that. And if you notice carefully, among those who are careful, there is a new file that has appeared. What is it called? Simply diary. Okay, that file is going to keep a copy of whatever happened on my screen. If I make errors, a copy of the errors will also be kept. It's a log, and that is what you can submit, okay, as evidence that you have done it. Okay, so now I have this function, my dot. I have listed it. I asked for help on it. I want to execute it. How do I execute it? I execute it by simply saying I need to define two vectors. So let me define vector A equals 1, 2, 3, 4. B equals 2, 3, 4, 5. So define two vectors. Okay. So if I say my dot A comma B, what happens? It transfers the control to that function called my dot and transfers the values of A and B that I have defined in the workspace. Do you understand? So the control goes there, and that function, all the lines in that function are executed, and if it sends out any output, the output will come back to the screen. So the control will go there, and A and B will be taken, and line 6 will be executed, it will be assigned to C, and C will be returned. Okay, let's try that. There it is. C equals 40. The answer is 40 in this particular case. Question?
Oh, when you like the vectors, how you name them A and B?
Yeah.
Do you have to name them A and B? Like, 'cause I know you did it in A and B, but this one and in the my dot function. Like, if you named them A and B in the function.
Good point. Let me do this. X equals 1, 2, 3. Y equals 4, 5, 6. My dot X comma Y. What do you think would happen? That's a very good perceptive question. So it doesn't have to be A and B. I was going to talk about it later. So these are called local variables to the function. So in the main workspace, you have defined two vectors X and Y, but you're calling my dot and passing the X and Y values. So what it does is it takes the X value, loads it into A locally inside that function. Similarly, it takes the Y value, loads it into B, and then executes it. Does that answer your question? Okay, so you can call it anything you want outside. So it's a way of isolating. This introduces the idea of a local variable versus a global variable. Anything that appears in the workspace that is in this list is called a global variable. Okay? But anything that appears inside a function is local only to that function. Okay? So here I can put a semicolon to suppress the output so that it doesn't print out as it executes, only the output comes. Okay? So notice carefully, when I did my dot xy here, it printed C equals 32. That output comes from inside the function where C is defined. And then this output ANS equals 32 comes when that function returns the value 32 to a place where I called it from, which is in this case the workspace. Okay? So if I execute the same function now, what would happen? Because I suppress the output for C by putting a semicolon at the end, I get only the answer out. Okay? Now let me define Z equals 1, 2. And then my dot X comma Z. What do you think would happen? What? Very good. Why is the error? Because they don't have the same length. I did not check that they have the same length, so MATLAB itself says matrix dimensions must agree. But if I want to put that error myself, give more specific error to the user, I can do that check here. Okay, I can say n is equal to length of A, m equals length of B, and if m not equal to n, then error vector dimensions must agree, or something like that. You are writing the program, you can put whatever you want there, and every if statement must end with an end statement. Okay, that's what says that if the condition is true, if the result of m not equal to n is 1, then it will execute. But if the condition is false, it will not execute that particular line, but move to the end and then continue on. Okay? Now you can save this and run the same statement. Statement is not inside a function. This is a different error. Pardon me?
Don't use space.
Yeah, you can put a space. Yeah, you need a space there to isolate the help. But the error, I think, is not from there. The statement is not inside any function. This end terminates the if statement, but can you find out what mistake I made? Capital IF. MATLAB is case sensitive. Okay, it should be F if. And it gives you the color code and tells you that that if matches with that end. So that was a mistake I made. So if I try this, now vector dimension must agree. That's an error message that I print out from that error statement. Okay. So any questions on this? You get an idea of what a function does. It takes a certain number of inputs, does whatever the calculations that you want it to do, and produces some output. So the input could be data from a plant, and you want to calculate the temperature deviations from a reactor, for example, and you want to do some analysis and output some results. Okay, so you'll be able to do more powerful calculations like that as we go along. Any questions? Now, here is another example. I think I'm going to ask you to study this example by yourself. This is how the exponential function. In fact, all the sine, cosine, tangent, all these functions are based on some series expansion. Okay, so you need to write a function to calculate that, but MATLAB does all this for us. So there is a function called, built-in function called exp in MATLAB. So if I say exp 2 takes 2 as the argument, calculates e to the power 2 and returns the value. How did it do that? It actually plugged it into the series expansion that I showed you in here. Okay, so it takes this series expansion. This series expansion goes all the way to infinity. We cannot be adding infinite number of terms. But what happens, that terms that are farther away become smaller and smaller because you have a factorial I in the denominator, which becomes a very large number. So you just need to take 20 terms or 30 terms or 40 terms. What does that depend on? How many terms that you have to take? You have to know how fast the series is. What is the keyword I'm looking for? Converging, right? You have seen this in math, right? Series convergence, okay? So how fast does the series converge? So depending on that, you will have to take a certain number of terms. So your program that you write must contain those tests. I'll show you an example of a program that I've written, arbitrarily truncating it. I think I called it my exp. Okay, can you see that in the back? Is that levels big enough? No? You guys, there's not a space there. You should come to the front. Let me see whether I can change the font size. Where would the font size be there? Is that better? Okay. So this is a function that I wrote that calculates the exponential function. So it takes the input x, produces the output. Okay. So what do you think the first line does? Finds out how many elements of x are there. For example, in that function, you can pass a vector. This is the natural world for MATLAB, right? So you can say exp of 1, 2, 3. That means, oops, exp of 1, 2, 3. That means take each value, e to the power 1, e to the power 2, e to the power 3, return me each one of those values. So if the input is a vector, the output must be a corresponding vector, each one containing, the same thing applies for sine. If I say sine of that, so if you input a matrix, the output will be a matrix where each element is the sign of that. So I want to mimic that behavior. I'm learning. I'm trying to copy what MATLAB does. So in the very second line, what I do is I create a vector of zeros. Everything is 0. Okay, what is its size? Its size is the same as x. So if x has 4 elements, I'll have 4 zeros. If x has 10 elements, I'll have 10 zeros. Then I set up a loop for I equals 0 to 110. I just pick some number, okay? Take 110 terms from the series. And sum equals sum plus x to the power I divided by factorial I. That is exactly the formula that you see in the, here, x to the power I divided by I factorial, right? But I'm adding that up. So initially I have 0 in the sum vector. Every time I go through that loop 110 times, each time I'm taking the next term, okay? And I keep adding to it, and I get the sum vector. I return that to y. Remember I said that somewhere in your function y must appear on the left hand side. That's what is returned. So this function will do exactly the function that the exp does. Okay, calculates the exponential. But what would be the difference between these two? It only takes 110 terms. The other one will be much more sophisticated. It will take 1,000 terms if it is necessary to take 1,000 terms, because if the series is slowly converging, you need more terms, and it will automatically take that. And we will come back and revisit this problem to see how to put those bells and whistles so that our program is as good as MATLAB's program. But here I'm just illustrating what is a function, what are its inputs, what are its outputs, and how does it look in the interior of the function. Okay, any questions on this function? Maybe let me just take 10 terms of that and illustrate the differences between these two. Okay, so if I say my exp 1, 4, 8, so I'm saying calculate the exponential of 1 e to the power 4 e to the power 8 using my function. Okay, and I do the same thing using the built-in function. Are they the same? At e to the power 1, they are pretty much the same, 0.0027 10 to the 3. Okay, that is 2.7. Both of them agree. Okay, at 4, the value is 54.4. Here it's 54.6. Why? Because I did not take enough terms in the series. Okay, so as the number increases, the difference becomes larger and larger. 2.43, 2.98. Okay, so that shows as the number x increases, the series becomes slowly convergent. So I need more number of terms. Okay, but to fix the problem, all I need to do is go back and increase the number instead of 10 terms, take 100 terms or 200 terms, things like that. Okay, any questions? Am I going fast? No? Okay. So we talked about the structure of what the function is. These are just notes for you to read. I don't want to go through it again, but I want to focus on the next problem. Now, if you ask for help on function itself, it gives you this help which tells you the structure of the function, basically what we have talked about. Okay. So you can read these things. So I'm going to do a fairly larger problem. And I'm going to illustrate how to take data, exchange data from an Excel spreadsheet into MATLAB, do the calculations in MATLAB, and maybe if needed, put it back into Excel. Okay? The reason is Excel is very commonly used in industry, and it is in fact plugged into data acquisition systems. So you may have a reactor that logs in the temperature at every minute or every 2 minutes into a file, which is automatically exported into Excel. So somebody, your boss may come and say, when you go into a plant as a process engineer, here is a spreadsheet that contains the data of this reactor temperature as a function of time from 3 different reactors. Okay, do an analysis. Tell me, for example, what was the maximum temperature the reactor had in 1 day? What was the minimum temperature? What was the average? How widely is it varying? Okay? Because the product quality, for example, if it's a polymerization reaction, may depend on how high the temperature is. So you want to control the temperature. So you want to know, for example, during the day, how many minutes or how many hours did it exceed a critical value, say 90 degrees. The reactor should not go above 90 degrees, but it fluctuates. Okay, so how many minutes or how many hours in a day did it go above 90? Analyze that and tell me those things, okay? So these are kinds of problems that you may encounter, and we will see how to write a program, how to exchange data, and things like that. Excuse me. So here is a spreadsheet, Excel spreadsheet. Are you all familiar with Excel? So anybody not used Excel? You start using in school nowadays, right? So Excel spreadsheet is basically, as the name implies, it's a spreadsheet. I don't particularly like Excel because it's a mumbo jumbo. It's like my desk. If you come to my office, everything is scattered everywhere, okay? There is no organization of data. But here I have 3 folders within that Excel, okay? Reactor 1, Reactor 2, Reactor 3. Again, guys, can you see at the back? Probably not. Let me try to blow it up, okay? So I want you to analyze, observe. The first column contains the time in minutes, okay? That's given in that first column. And the second one contains temperature in degrees C, okay? And what you notice the time difference between the sample, this is called the sampling time. So every minute, this reactor is logging in its temperature. So at time 0, start of the day, it's 124. Within 1 minute, it goes to 117, 121, 117, 99, then it shoots up to 138, whatever, okay? So the sampling time here is 1, the interval between the time that you sample. If you go to reactor 2, the data is given with a sampling time of 2. So every 2 minutes, it writes out its temperature, okay? And something is wrong with reactor 3, so it does funny thing. What is the sampling time? So it's random, it's randomly varying, okay? First time it sends out in 4 minutes, and then the next minute, 5th minute it sends out, and then in the 8th minute it sends out. So some data is being lost as it is sending, okay? So there is some communication problem, whatever, but this is the data that you have. And remember, your job is to take this data and write MATLAB functions to be able to do some analysis. I'm using MATLAB, but people may want to do this in Excel itself. Okay, a lot of the questions that I'm going to ask you, you can probably do it in Excel as well. Okay, so the questions, let me just review the questions. What is the average temperature of the reactor? What are the maximum and minimum temperatures? What is the standard deviation in the temperature? And the fourth one is a more difficult one. How many times did the temperature exceed the critical value of 70 degrees? So I specify the critical value of 70 degrees. So how many times? How many number of times in the data set? Okay. Print the time and the temperature value and the next one is, did you have a question? The next question is, print the time and the temperature at which this condition was satisfied, that the temperature was greater than 70 degrees. In fourth, what are you asked? You are asked, how many times did the temperature exceed? Okay, if you have 1,442 data points, did it exceed 800 times? Did it exceed 900 times? And then the next question is, at that time, print the timestamp and the temperature at those times where the temperature exceeded, because you want to know, is it happening during the daytime or in the evening time, or is it random? You want to diagnose what the problem is. The next question is, what is the cumulative total time for which the temperature was above the critical value? So in a day, how many minutes total was the reactor above that critical temperature? And the last one is, generalize it to make the critical temperature a variable. It doesn't have to be 70 degrees. I could say tomorrow, check if it is greater than 75 degrees or 80 degrees. Okay, make that as a variable. So we are going to use a lot of these functions. Okay. So now, how do you want to approach from this point? If I show you the function and explain it to you, is that good? Or do you want us to write the program, make all the mistakes, and learn from them? My point is, you should not be afraid to make mistakes. Okay, when you are writing a program for the very first time, you will make mistakes, but you need to develop the ability to find out what those mistakes are. And that will be your most frustrating part in this current assignment. You write something, it doesn't work. It spits out some error message which doesn't make any sense. Okay, so you need to develop techniques for deciphering that and trying to figure out what that particular issue is. Let me just flash how that function looks like so that you get the overall structure, and then we will start writing it ourselves. Okay, so the first one I called my first function. Okay, does that make any sense? We are following some of the basic rules: function, alarm, my first function, and then some input. Okay, so it takes time, temperature, and the critical temperature as inputs, and then sends out the values that I'm asking it to calculate. We will build this one by one, slowly. Okay, and then I put a set of comments. Okay, and then I will explain what this means pretty soon. And a statement like this you should be able to understand. Calculate the mean temperature. Okay, and then print it out. So let's just go and write this from scratch. Okay. So when I ask it to write a new function, it gives me the template already, and I'm going to call it as critical T. I want to get the critical temperature data out. Okay, and I'm going to call it reactor 1. So I'm analyzing the data for reactor 1. So these things can be anything that you want, and the input I'm going to take as the time and the temperature. Two arrays. Time is one array and the temperature at that time is the other array. Okay, so these are the two inputs. From that I want to calculate those values where the temperature was greater than the critical value and print them out, and print all the other outputs that we wanted as well. So we will look at the question and develop one by one, so that it basically slows me down and you understand the idea better. So I want to put some help. So reactor 1 analysis. Okay, and another comment takes time and temperature as input. Calculates statistics, whatever you want to put. Okay, so I'm going to assume at this stage that two variables, t, the small t and the capital T, are available in the workspace, and when I call this reactor 1, those values are going to come and then it will do the calculations. So let me save this file, save as, what would I give the name? Reactor 1 already gives me by default because it looked at the function is called reactor 1, so it calls this function as reactor1.m. Okay, I'm happy with it, I'll accept it. Okay, and the first question that I was asked is, what is the average temperature? Okay, so average T equals mean of T, semicolon. Guess what does that do? Now here you need to know that there is a function called mean, which takes an array and calculates the mean of that array and returns it, right? So mean basically calculates any average of a vector, and it is stored in a variable called average T. I guess maybe I'll call it as capital T. Okay, and then I want to display that output. Okay, so to display there is another function. This is probably the first time we are seeing this function. It's called fprintf. Okay, it's coming from C language syntax. Okay, so it is basically a printing command which also takes an input and produces the output on the screen. Now when I write this, it already gives me some help. Okay, what do you want to put as an input argument? In this case, I want to just write the string. The average temperature of reactor 1 is. I can put any string like that, and then I need to place in that some placeholders. So %G is called the format specification. So it says use the general format and insert the number at the particular position. And then \n says after you print this out, go to the next line. Okay, and then you end the quotation mark, put the comma. So that is your first input argument. Remember, fprintf is a function, it takes inputs. The first input argument is a string. The string has embedded in it placeholders where numbers will be inserted. Okay, and I can tell next what the number I want to print is. So it's going to be average T, and I close the parenthesis. So let me go over this carefully one more time, okay? F print F, parenthesis, the first argument is a string, and in that string, I put a placeholder %G. So where it sees a %G, it's going to replace the number. Where does the number come from? From this argument. So it will insert that number average T in that place, in the general format. And the last part is \n says go to the next line. Okay, if you don't have that, it will print that and the cursor will stop right there on the screen. Maybe we will try both of them. Okay, any questions on that? No? So I have saved this function. Let me just show how this executes, and that way you can build gradually, test it out as you add a few lines and see whether it works as the way you expect, and then add more of those features. Okay, so I need to now, in the workspace, let me clear whatever I had before. Oops. Clear. The workspace is clear. I need to import these values, T, small t, and capital T. How do I do that? In Excel, there is something called add-in. Okay. When you pick that add-in, so there is something called Excel link, which links MATLAB and Excel. And when you have that activated, you will have this folder called add-in. And in here you have a few commands: start MATLAB, put matrix, get matrix, evaluate string, get figure, wizard preferences. Okay, these are the few commands that you need to pass the data between the two places. Remember, my workspace was empty. I cleared everything. Okay, so here I come and select from line 2 all the way to the last data point that I have here. Where is it? Oh, I'm in reactor 3. Let me go to reactor 1. Okay, let me take with that. Okay, I have 1,440 points. I select them. I select those two rows. Okay, and then I can go to this and say put the matrix. When I click put matrix, it says, okay, what do you want to call it in your workspace in MATLAB? I give it a variable temp. Okay, now what do you think would have happened? In the MATLAB workspace, you would have a variable called temp, and all those values have come. What would be the size of this matrix? 1,441 by 2. Okay, so there are 1,441 rows, 2 columns. Okay, from this I want to extract my time and temperature. So time would be, you have to help me. What would this be? If I type that, you sit there and you say, ah, that looks easy, that looks easy. But when we start doing it, it is not as, you have to recall what we have seen. Now I'm asking you to recall what we did 2 weeks ago, array addressing. So I want to pick all the elements in the first column. So how do I do that? I put a colon, comma 1. Colon means everything in that column, all the rows, comma 1 says the first column. So take the entire first column and put it into a variable called T, and I don't want it to print out. If I don't put semicolon, it prints out the whole thing. Okay, but if I put a semicolon at the end, it suppresses it. Okay, now you tell me, how would I extract the temperature? Very good. Now it's easy, right? There it is. So in the workspace, keep watching there. Okay, originally temp was obtained from the Excel spreadsheet using the put command from Excel. Okay, and then I've created 2 variables T and T. Okay, so if I want to execute this particular problem, what would I have to do? What do they call that? Reactor 1. Right? Type reactor 1, just to make sure that all the contents are there. Okay, so if I now to execute this, all I have to say reactor 1 T comma capital T. So I have defined these 2 variables. I can call it X, Y, or whatever you want. This function requires 2 arrays, takes these 2 arrays, and at present calculates the average of the second one. So the average temperature of reactor 1 is 105.055. Okay, so what produced this particular output? That line? Which line here produced that output? Am I going fast? Line 7. But I have this bad habit. If somebody says that, I assume everybody is okay with it, everybody follows me. Am I going fast? Are you guys okay? You're following? You are following what this particular function does so far? It takes two arrays, lowercase t and uppercase t. We assign the meaning that the lowercase t contains the time, uppercase t contains the temperature from reactor 1. Only we know that. For MATLAB, it's just a set of numbers, right? Then it says, line 6 says, pass the value of t to the function mean. So mean is a function that takes an array, calculates its average, and sends it out. And when it sends it out, this line 6 stores it in average t. Okay? The next line says, let's print that out to the user. Okay? And that is the syntax of a fprint, the print command, which takes that value that we have calculated and places in this position, person G. Okay? So if I didn't have \n, what would happen? Let's watch that. So the cursor stays there. It prints out, but it stays there. So to return it to the next line, fprintf must have \n as the last command all the time. Okay? Now let's continue with the next part of the question. And I have put all these three functions and the answers to all the questions in the notes. If you are not able to complete all of them, you should study it by yourself and come and ask me if there are questions. Okay? What are the maximum and minimum temperatures? Okay, so how would I fix that to answer that question? I would put a line called min_t. It's a variable that I create, but there is a built-in function called min, and I pass t to that. Then max_t is a variable, and there is a function called max, and it creates scans the entire vector and picks out the maximum value. Okay, then I want to print these out. Okay, I can copy that line and paste it here, and then here I replace the minimum temperature of reactor 1 is, I replace this by min. Cut and paste, so the program writing becomes easier, right? And then copy that and paste it and change this to max and change that to max. So now you have a function that calculates the average, the minimum, and the maximum. Save that. Pardon me? Yeah, thank you. So what would happen? This would have been a nice thing. It would print the first line, follow that, on the same line it will print the second output, on the same line it will print the third output. Okay? If you don't have /n. Oops, in the wrong place. That is very alert. Thank you for catching that. /n. But you should not be afraid to make such mistakes. If you forget about it, run it, and you see, oh, this is what is happening. Why is this happening? And what do I need to do to fix it? Okay. So now go and run that. So the average temperature is, the minimum temperature is 60, the maximum temperature is 150. Okay. Any questions? The problem gets more complicated. What is the standard deviation? Well, I guess that's not very complicated. How many times did the temperature exceed the critical value of 70 degrees? Okay. How would I answer that question? Anybody wants to take a chance? You may want to practice this in the workspace, because we have t in the workspace. You can say, for example, find t greater than 70. What does that do? It finds all the indexed positions when the temperature was greater than 70 degrees. Okay? But if I just put, instead of passing it to find, if I just say t is greater than 70 degrees, what does it do? It simply gives you true or false for every data. If it is 1, that means it was true. If it is 0, it is false. Now, if I say sum t greater than 70, what would that do? That gives you the answer, right? So 1,276 times in the data set, the temperature was greater than 70 degrees. Okay? So now we need to encode that into the function. Okay? So you go to the function and add these two parts. stdt equals, there is a function called, I think it's called standard deviation, std. I forget that this would happen, okay? There are thousands and thousands of functions, so I would not remember all the syntax, okay? So you can go ask for help std, something like this, not found, help std. There it is, standard deviation. Calculates the standard deviation, okay? So the name of the particular function, you don't have to remember, but here now pass t, so it calculates the standard deviation, and then copy that, and standard deviation. STD. Okay. The next trick that we figured out was how many times. Okay. So count equals sum t greater than 70. Fprintf number. I think we're almost out of time, right? Number of times exceeded %g /n and count. Okay, so that counts, the line 15 counts how many times that condition was satisfied, and line 16 prints that out. Okay, so we will continue with it in the next class to develop the ability for function creation, but study the rest of the notes. That will help you to do your current assignment.